Lancashire, North Wales and Cumberland, where the steel industry was first created, and where the ironmasters built Britain's industrial power, making steel goods for the whole world. In the northwest today, iron pours from 18 huge modern blast furnaces. Compare this with the blast furnace of hundreds of years ago. In ironworks like these was smelted iron ore dug out of the earth of Lancashire. The trees of the forests were burnt for the charcoal needed for smelting. Iron ore, charcoal, and limestone were heaped in these old stone furnaces. The flames roared up the chimney, and the iron trickled from the hearth. This is how pig iron was produced for more than 200 years. Pig iron was used to make cast iron goods, but it was brittle. It still had to be made tough. It had to be made into steel. Then, in 1856, Henry Bessemer invented a new way to turn iron into steel on a large scale. He poured molten iron into this converter and blew air through the iron, burning up all the impurities and converting the iron into steel. Today, his little converters have been replaced by giants like these, but the process is the same. Molten iron is poured into the Bessemer converter, 25 tons from this ladle. Now the man in charge, he's called the blower, starts the blow. The air is blown through the molten iron like bubbles through lemonade. The impurities begin to burn with a dull and smoky flame. The blower has to watch this flame all the time. Gradually, it changes as the carbon in the iron is burnt. It becomes white and dazzling. The blower has years of experience behind him. He has only the length and color of the flame to tell him when all the impurities have been burnt. The flame gets shorter and hotter. He needs all his skill to decide just when to stop. Now, iron has become steel. In less than 20 minutes, 25 tons of steel have been made from crude molten iron. The blower can relax until the next charge is ready. These converters at Workington produce high-grade Bessemer acid steel. Modern steels are harder and tougher than Henry Bessemer ever made. One way of shaping steel is to forge it like the blacksmith hammers out a horseshoe on an anvil. This 20,000-pound steam hammer at a Manchester works is hammering out steel, but it is for gear wheels, not for horseshoes. This man is throwing sawdust on the forging to stop it from sticking to the hammer. It calls for both strength and skill. So another blank is ready to be made into a gear wheel. In this Manchester works, steel is shaped in another way. It is rolled into wire rods. This man controls all the electric motors that drive these 9 mills. A billet is pushed into the furnace to heat for several hours before it is rolled. A rolling mill is like a pair of mangle rollers, and each pair of rollers squeezes the steel a bit thinner. As it gets rolled thinner and thinner, of course the rod gets longer and longer. The mill has electric controls to save work. This is a photoelectric cell. When the red-hot rod passes it, it acts in a split second to make the shears cut off the rough ends of the flying rod. When it comes out of the last of the 9 mills, the rod has been rolled out to 100 times its length, and it is coiled up red hot. Running into Shotton near Chester, you cross the famous sands of Dee, and here, where Mary called the cattle home, a huge new steel plant is being built. This marshy land used to be covered at high tide, but with the help of Dutch engineers, it has been built up ready to take a modern melting shop. The Dutch, who built half Holland out of the sea, knew how to tackle this job. Men from Walcheren came to Britain to help in a job we don't often tackle. In 9 months, they pumped over 6 million tons of sand to build gigantic foundations. Concrete posts had to be driven into the sand to take the weight of the building. This is called pile driving. Then the melting shop was built on the piles with some of the largest welded girders in the world. When you see a huge works like this, growing day after day, it gives you hope for the future. There may be a job there for me. In Britain's new steel plants, new processes of steel making are being tried out. This is an electric arc furnace, the latest type. Big electric arcs are used to melt down scrap and turn it into the finest alloy steel. At this works in North Wales, they're trying out a new idea, blowing oxygen into the molten scrap to burn out all the impurities. This is an exact scientific operation. Before the oxygen can be blown in, everything must be known about the molten metal. A sample is taken. The temperature of the metal is measured exactly with a thermocouple. In the old days of steel making, the sample of the metal was examined only by eye. An experienced steel worker judged the condition of the metal by just looking at this fracture. In this works, precise scientific methods are used. The sample is sent off immediately to the chemical laboratory. Here it is analyzed to find out what impurities remain in the iron, and in particular, how much carbon. Speed is essential, as work in the furnace cannot be carried on until this analysis is known. Within a few minutes, the result is phoned through to the first hand of the furnace. Now they can go on. The oxygen is turned on. It starts to attack the impurities and burn them away. Now the carbon is being burnt. The heat is intense. The slag begins to run off the top of the metal. Even the pipe supplying oxygen is burnt and gradually has to be pushed forward. The process must be stopped at the precise moment judged by the first hand. By using oxygen like this, the steel is made in a shorter time and with less electric current. Scientists have given the steel industry a new technique in line with the discovery by Henry Bessemer of his famous converter.